So in question number 1 on slide 2, I think everybody did a great job of if it is a 6-sided polygon, then it is a hexagon, right? And then the contrapositive, we switch it around and make it not P, so not hexagon, then not 6-sided. So contrapositive, we switch the order and negate, right? Morning, Joseph. I'm gonna put the link for you in the chat if I can get there. Oops. Got too many things in my hand. And we'll go to question 2. Question 2 says quadrilateral ABCD with these points. Write the equation of the lines of symmetry. So first thing I would do is draw those lines of symmetry. So where can I fold this shape in half? I can fold it vertically from A to C. And I can fold it horizontally from D to B. This intercept is on the x-axis and it's number 2. So this line is x equals 2. And this intercept is at 4 and it's on the y-axis. So this horizontal line is y equals negative 4. So if you can draw in those lines, look for the intercepts and whatever axis they're on. This one's going to be x equals 2 because it's on the x-axis. This one's going to be y equals negative 4 because this is the y-axis. Y equals negative 4. Does that make sense? We didn't practice a lot of that, and maybe since we went out early, you didn't practice a lot in algebra. So that's something that, is not that hard. It's just if you don't know it, you don't know it. Okay? Definitely stop me if you need me to stop if I go too fast. Determine the longest side. So I was so happy to see that everybody who started this question found the supplement, 109 and 71 equal 180. And then you can subtract 71 and 45 from 180 and get this angle up here. So let me see. Does anybody know what angle L is? 180 minus 71 minus 45 is going to be, I'm looking in the chat, but I'm not.
L?
64. Yeah, angle L.
Oh, yeah, 64.
Okay. Can you guys hear me okay? Yesterday, my computer was glitching out. So if we're looking for the longest side, we want the biggest angle. So the biggest angle here inside the triangle is 71. So many people drew arrows over to this side. A lot of you put L, and then later I realized that that was the L for the longest side. When it's asking for the longest side, we're looking for LM because that's the name of that side. So if you had L, I totally understand your notes now. I just am still a little sleepy. So those questions should be pretty easy. We should get all of those. Number 5, it's again just trying to figure out what tool to pull out of your toolbox. If I've got two sides of a triangle that are 12 and 8, and I make a really acute triangle, I want to do 12 minus 8. 12 minus 8 to figure out what this missing side could be. So that's going to be 4. It has to be bigger than 4. And if I have a 12 and an 8 and I make an obtuse angle, that's getting closer and closer to be a straight line. So here I want to do 12 plus 8. You subtract them to get the small number and you add them to get the big number. So I want everything between 4 and 20. Triangle inequality. If you've got two sides, you want to subtract them and add them and do everything in the middle. Yes, no, maybe so? Okay. Quadrilateral PQRS is given, and we know that PQ and RS are parallel. So PQ and RS are parallel. and PR and QS are parallel. Luckily here, those are shown. Determine which two triangles are congruent and write a congruency statement. So I loved that some people went ahead and did those alternate interior angles and wrote angle, side, angle. Love, love, love that. And then we've got to write a congruency statement. So if I start with P and then go to Q and then go to R, triangle PQR is congruent to which triangle? What letter goes with P?
S.
S, absolutely. So P and S go together, and then I go to Q. So if I go across that one arrow line, I've got to go across that one arrow line over to R. And then I've got to go across that reflexive side to Q. So this is going to be the answer that they're looking for if it's a multiple choice question. Love, love, love if you put that in there too. Questions on that one? I know we kind of rushed through the similar triangles unit, so a lot of people still not feeling very confident about those. Okay, I'm looking at the chat to see if anybody's sending me messages there. You know, I love getting messages. Okay, right triangles. If I know this is supposed to be a right triangle, I can draw a picture, right? My longest side is always the hypotenuse. Oops. And then I can put the 3 and the 4 wherever I feel like it. And I know it's right triangles, so I'm thinking Pythagorean theorem. If I square these and put that in my calculator, then I get 3 plus 4 equals 5. Is that a true statement?
No.
It is not. So if that's not a true statement, then these are not right triangle, or this is not a right triangle, because the Pythagorean theorem isn't true. Okay. So if you're given a triangle and you're asked, is it right? You just test it with the Pythagorean theorem. If the Pythagorean theorem works, then it's a right triangle. If it doesn't, then it is not. Number 8 is what I call a time-sucking question. You have to really kind of just brain dump everything you know onto it. So if I plot these points, right, I'm trying to see what kind of quadrilateral this is. I want the most specific name. So if I plot those points, 1, 2, 1, that's A, and then 4, 1, 2, 3, 4, and then 1, 2, 3 and a half, and then 6 and 1 and 4 and negative 1 and a half, 4 and 1 and a half. And then if I connect those, do these lines look parallel? Those lines look parallel? I've got a slope of up 2.5 and 2, and then up 2.5 and 2. I think these lines are parallel. In fact, if I look at those lines of symmetry, these are definitely parallel. All of these triangles are congruent. So I know all of these sides are the same size. And this is perpendicular. So I think this is a rhombus. If these horizontal pieces and these vertical pieces were the same, it would be a square. But because this is a half, this side is 2 and this side is 2.5, it's not a square. So you just kind of have to draw these out and see what you can do. And this will definitely be like a multiple choice question. That's a tough one. Last question. Sabrina would like to create a collage for art class. with regular polygons with an interior angle of 156. So I love that some people drew some polygons and put 156 as the interior angle. If you know the interior angle, what's the exterior angle?
24.
Absolutely. You got to remember interior plus exterior equals 180. So if you do 180 minus 156, you get 24. And then you got to remember another equation. 360 divided by the exterior angle gives you the number of sides. So once I know that exterior angle of 24, 360 divided by 24 equals what? Anybody? I got 15. Is that what you got, Victoria?
Yeah.
Awesome. So definitely a couple of things to remember. These are not on the formula sheet. You just are expected to remember them. They will come up in the SAT as well, so don't brain dump this information. You've got to know that n minus 2 times 180 for interior angles. And you've got to know this interior plus exterior equals 180 and 360 divided by exterior equals n. All three of those are not going to go away at the end of the SOL. They will come back to you for the SAT, okay? How many sides are in a regular polygon that you use? Explain how you use the exterior angles. Oh, so that's just the explanation of what we just did. Okay. Questions on any of that? Do I need to go back to any of the slides? Anybody miss anything? So we've got equations for polygons. We've got plotting and identifying the quadrilaterals, Pythagorean theorem for right triangles, labeling everything and then finding the corresponding parts for congruent and similar triangles, subtracting to find the smallest side, adding to find the biggest side, triangle sum, and then the longest side is always opposite the biggest angle, drawing those lines of symmetry and then looking for the intercepts. And then we've gotten so good at logic, right? All right, I'm going to close that out. There are a couple of things that I want to kind of bring your attention to. So if you meet me in Schoology or just want to look on mine, it's totally up to you. For all of those who are taking SOLs, and even if you're not taking the geometry SOL, you might be taking another SOL, right? Up here in our banner, you've got a link to some SOL information, but there's another link that I just put in there. It's called Test Day Information. So if you click on that, it'll give you everything that you need. There are some of you that haven't even been in the building yet that are coming in to take SOLs, maybe on Monday Monday the 25th. These are the things that you need to know, okay? When you arrive at school, you need to get here by 7 o'clock. Testing will start promptly at 7:20. If you're not in your testing room ready to test at 7:20, you won't be allowed in, okay? So you definitely want to get here by 7 o'clock. If you get here early, there will be breakfast served, okay? So you come in the main doors of the school and there'll be signs, there'll be lots of teachers there to help you figure out where you need to go on the day of the test, okay? What to bring? You want to bring your charged school-issued Chromebook. You can only test on a school-issued Chromebook. And you definitely want to bring yours, bring it charged. If it's not charged, bring a charger. There will be some spaces and ways to sit near a charging station. Maybe your Chromebook is a little older and it doesn't hold a charge very well. If you know it doesn't hold a charge all day, bring your charger with you. Okay? Questions about any of that? You definitely want to wear a mask. You will not be allowed in the building without a mask. This is new. You want to bring your own pen or pencil. I think they're trying to limit the amount of things that they're passing out and passing back. So you definitely want to bring your own writing tool. That's a change from years past where we've had to give you one. Okay. And then definitely a positive attitude. I think everybody's going to do great when they come into test. A couple of other things, what to do after the test. So this was a change that was just told to us yesterday. Normally you have to stay in your testing room after you finish until we consolidate rooms. This year, the test is going to start at 7:20, but if you are done, you may leave at 8 o'clock. Okay. So anytime after 8 o'clock, whenever you finish, you're going to be able to get up, leave the testing room, and leave. If you have a parent pickup, you can go to the cafeteria and text them and have them come pick you up. If you can drive, and I'm talking to like my sophomores mostly right now, if you can drive, then you can just go out, check yourself out at the main office and leave, or at security, not at the main office. Okay. If you're riding the bus, you are kind of stuck there until 2 p.m. So you definitely want to bring your charger. You'll be able to go to the cafeteria and log on to your regular Zoom classes. Make sure you bring some headphones, okay? And then there'll also be lunch served in the cafeteria that day. So if you come into test and you have to take the bus, then you'll come in at 7 o'clock. You'll have breakfast. You'll do your test. You'll go to the cafeteria. You'll hang out, do the rest of your classes on Zoom, get lunch in the cafeteria, and then leave on the bus at 2 o'clock. Okay. Questions about all of that? I know this is a lot. Okay. So definitely a big news day yesterday. One of the news items that was local was that our superintendent, Mr. Spence, has proposed that we come back to school. And for us in high school, that means coming back February 9th. Okay. So have you guys heard about this? Anybody?
Yeah.
Okay. So February 9th, we're scheduled to come back to school. This is not official yet. It still needs to be approved by the school board, I think next Tuesday. So this is not set in stone. This is a proposal, right? And they'll still monitor the schedule. What we would do is we would come back to like the schedule that we had when we were yellow. So the beginning of the alphabet, I think, comes Tuesday and Thursday, or Tuesday and Wednesday. The end of the alphabet comes Thursday and Friday, and Monday is still a virtual day. If you're an option 2 student and you're still at home, all the classes will be hybrid. So we'll still have some students face-to-face and some students online and some students just online. Questions about any of that? Okay, I'm going to stop sharing my screen for a second because I just feel like I need to open the floor to anybody who has, any concerns or anything about what happened yesterday up in DC. I don't want to get into a political debate on like who was right or who was wrong, but I know my heart hurts a little bit for all of the things that were going on yesterday. So I just kind of want to open the floor, open the chat to anybody if you have anything that, you feel like you need to get off your chest. No, Congress did come back in session and they did what they needed to do. And Biden and Harris are officially our candidates. They'll be sworn in 2 weeks. But there was a lot of unrest up there. Yeah. I grew up right outside of DC. I went to school in the city. So that's like my home. That's why it's like kind of hitting me hard. Okay. I just thought I'd open that up because, geometry is not the end all and be all of the world. It's a lot more beyond geometry. All right. I agree. Some people are sending me private messages. I was just embarrassed to see it. My son's living in Italy right now, and he texted and called and was like, oh my God, the rest of the world thinks we're crazy. I was like, yeah, well, we are a little crazy right now. All right. Well, let's start our lesson. Hopefully you guys have other opportunities to chat about those kinds of things later today. I lost my chat. There it is. So a couple of other people are chatting about switching classes in the middle of the school year. Yeah, this 4x4 schedule is not for everyone. I have taught 4x4 classes every year that I've been at Kempsville, and so I'm kind of used to it. But it's definitely a struggle for sure. So another person's asking about vaccines. So this is a great discussion, you guys. I'm glad you're feeling free to ask these questions. As I understand it, the nurse in the building is going to have vaccines available for the faculty as soon as we get into the 1B category. Right now, vaccinations in Virginia are in the 1A category, so they're only vaccinating healthcare professionals. I kind of look at the numbers because my daughter's in the healthcare field. She's supposed to get her vaccine this week. So it's going to be not mandatory. It's going to be optional, and they're going to do teachers first. And then as kind of the rollout for the state and the country happens, students will have an opportunity. And I do not know whether you guys will have the opportunity to get your vaccine in the school building or whether you'll have to go to your own healthcare provider, patient first, whatever, wherever you go for your healthcare. So I just don't know at this point, but I think teachers will get it before students will. I'm kind of looking in the chat, see if there's anything else. This is like an open forum, guys. So if you want to unmute yourself, go feel free. If you want to put it in the chat, feel free. And we'll kind of do this tomorrow too, because I know sometimes questions kind of linger and you're not quite sure who to ask or how to ask or where to ask. Okay.
I have a question.
Yeah.
So, do we have exams this year? One of my teachers told me that we don't have any exams this year, and I just wanted to ask again.
So that's a great question. There are no official final exams. So that being said, the district, and I'm going to switch my screen for a second to give you a visual. The district has pushed out several assessments for various content areas. So I am not giving you a final exam. For those, 13 students that need to take the SOL, they're going to need to take the SOL. But even those students, I'm being asked to give this geometry end of year assessment. So it's sitting right here. We'll have time to start it on the 27th, which is a Wednesday. And then I'm going to ask you guys to finish it on the 28th and the 29th. It's 45 questions, I think. I did not make it. The district made it. What they're trying to do for math, at least, and I think every math class is going to have to do this. I don't know about other content areas. Is they're trying to figure out where there are holes so that we can change the pacing and modify the pacing for the next couple of years to make sure every student gets all the information they need in order to graduate and be successful in college math. So the answer to your question, because I know that was a long answer, the succinct answer is no. There are no final exams this year for either term 1 or term 2. However, some subject areas, math being one of them, are asked to do some kind of end of the year assessment for the city. Does that make sense?
Yeah.
Okay. So why are we bothering with SOLs is another great question. The answer to that is it's federally mandated. In order for Kempsville and Virginia Beach to be accredited schools and districts, we have to go through this end of the year testing to show that we're doing it. And it's a federal rule. And the Secretary of Education, currently under Trump, has not lifted the requirement. And the incoming Secretary of Education under Biden has said that he's not going to lift it either. So it's a federal law that we have to abide by. And in order to make it a little bit easier on everybody, the state decided to lower the expectation because they know that we haven't been in school 5 days a week. We haven't been face to face. A lot of people have had connectivity issues and health issues and financial issues for that matter. Like, it's just been a really tough year. And so the state is trying to do what it needs to do in order to meet the federal guidelines. The school district is trying to do the same, and so is Kempsville High School. So it's just kind of all of those layers of politics that are kind of keeping us with the SOLs. Yeah, somebody else is kind of drawing a contrast between the Black Lives Matter protesters in the city versus the Make America Great Again protesters, and how they were treated very differently. That's one of the things that breaks my heart, especially being from DC. It's just, it's not, I don't know. It's just not right. There's nothing right about what happened yesterday. Good questions, guys. I think moving forward, we just got to do our part to make it, be nice to people. I just don't understand why it's so hard to be just a nice human. That's what we need to learn in school. Forget geometry. We just need to be nice humans. So we've talked a lot about a lot of things today. I love it. It makes me feel so connected to you guys. We do have some geometry on that note to look at. So if you meet me in today's folder, we're going to try to start talking about sector area and arc length. And then there is a quiz for homework tonight. So I want to try to make sure we're ready for that. We did the warm up. You guys did great. If your last name is A through J, I want you to open this Jamboard. And if your last name is K through Z, I want you to open this Jamboard. So we're going to open these up. And just like yesterday, I want you to go through the slides and see what you can add to them. So on one of them, you've got circles that are all tangent to the x-axis. And on one board, you've got circles that are tangent to the y-axis. What I want you to do is write the ordered pairs for the circle centers, and then write the equations the best you can. Okay, so remember the equation of a circle is going to be x plus a number squared, and we can just put that little caret and squared in order to do squared, and then plus, and then y plus some kind of number squared, and that's going to equal the radius squared. Okay, so that's the equation of a circle. So when you're on your Jamboard, x plus a number squared plus y plus a number squared equals r squared. So see if you can write the equations of those circles. You're on that Jamboard. Can you add in the equation of the circle? If you can't add the equation of the circle, can you just write the ordered pair? Like this one is -5, 5. So we could put in the ordered pair right here, -5, 5. We could put in the ordered pair here, 5, 5. I'm going to stop sharing for a minute so you can have full control over your screen. And on your Jamboard, I need you to add in whatever you can add in. You can find the area of each circle. Remember, area is pi times r squared. We can go to the third slide and get circumference. So find something that you can do. Don't see much activity, guys. Nice. I see somebody finding the circumference. I see an area. See some circle centers. Nice work. Perfect. On slide 4, a couple people writing the percent that the circle is shaded.
Miss Goucher, I have a question.
Yeah.
When we type the pi, do you want to type 3.14 or the pi sign?
It doesn't matter, whichever one you want to do. So when we get, because some people do the 3.14 and some people use the pi button, our decimals might be a little bit different. So as we have different decimals, you just need to kind of shout out, hey, I got this instead, and we'll confirm that that's also the right answer. It's a lot of rounding and what's the closest answer when we talk about circles.
Okay, wait, how do we find the arc for them? Are we like on that?
So on the 4th slide, so another person said, how do I get there? If you're in today's folder in the sector area and arc length page, you should be able to click on the Jamboard for your last name. And then on Elise, I think you're asking about the 5th slide.
Yeah, it's the 4th, 5th slide.
So for those ones, you want to find the, like on that blue one, I think this is yours. Are you on the x-axis slides or the y-axis slides, Elise? Does it say circles tangent to the x-axis? Yeah. So like for this blue one, you want to find the circumference. Circumference equals 2 times pi times r, but then divide by 2 because you're only looking for the arc that goes halfway around. So you would do 2 times 3.14 times 3 and then divide that by 2 because you only want half of that circumference.
Okay.
Yep. So we're kind of trying to put together everything we've learned over the last couple of days. Circumference, area, radius, and circle equations. Nice work, everybody. All right, guys, do we want to look at the y-axis slides or the x-axis slides? Do we care? Let's see how the y-axis people did, because that's the one I'm on. So no judgment here. There we go. I agree. So I've got a circle, and we put in the circle center. So now we need to put in the equation. What did we learn yesterday about the equation? Did the numbers stay the same, or did they change sign? If my ordered pair is x minus 5, then I put in x plus 5 here, right? They're backwards. And then it's always a plus. And then if I have a plus 5, then I need y minus 5. And then the end is always the radius squared. So the radius is 5. So I'm going to do 5 squared. What about this equation with the 5 and the 2? Help me write that one.
X minus 5 squared plus 5 minus 2 squared. And then would it be 5 squared?
1, 2, 3, 4, 5. It would be 5 squared. I was having a hard time reading those. Nicely done. What about this negative 3, 4? What should I type there? Somebody else. Is it x plus 3 or x minus 3?
Plus 3.
Absolutely. So x plus 3, we got to just remember that those signs change. And then instead of a minus 4, I need y
Plus 4.
plus 4. And then the radius is always squared because it's almost like we're finding the area. So is the radius of that circle. Is it 3 squared?
3 squared.
I'm going to move this one over here just for space. What about the 2, negative 2? Help me write that one. X plus 2 or minus 2?
Minus 2.
Minus 2 squared plus y plus 2 or minus 2? Plus 2 squared, and then equals, what's the radius of that circle?
2 squared.
Oh, wow, we've got a lot of 2's in there. And then our last one, this one, is that negative 1, 0? So if I have negative 1, 0, x plus 1 squared, and then y, do I have to do plus 0? Or can I just leave that without anything?
Even without anything.
Leave it without. So it's okay if you put that plus 0, but know that you're more likely going to see it like this with just nothing. And then what's the radius of that little tiny circle?
1.
1. Do I have to put the 1 squared? What is 1 squared? Is 1 squared just 1?
Yes.
Yeah, so you can put the 1 squared, or you can just leave it to make it a little more clean. Okay? I know this little notation is kind of weird. That just means that that's an exponent. It's called a caret. I have no idea why it's called a caret. It's just, I don't know, because math people are weird. So over here, love these. Area of a circle. So 3.14 times 25, that's perfect. 3.14 times 1, perfect. 3.14 times 9. Excellent. 3.14 times 4. And then 3.14 times... I think this one might need some fixing. What's a better answer for this one? What did this person do wrong? I think this is the circumference, not the area. And it's so easy to make that mistake. So if that's 2 times pi times r.
78.53.
Yeah. So if we come down here, we could do area equals 78.53 or 54. Again, that's a rounding thing, right? So be careful with circumference and area. I make that mistake occasionally myself. It's just, you know, your fingers get going too fast in the calculator and you're not thinking about what you're doing. We've got the circumference. That's perfect. We've got the circumference. Got the circumference and circumference and circumference. Beautiful. Okay, so this is kind of the lesson that we're getting into now. In these pictures, we want to find the total area and then find the percent that's shaded in. So in this last slide, the total area was 78.53, right? So I'm just going to take a little shortcut. If this whole area is 78.53, 78.53, and I've shaded 50% of it, how do I find 50% of 78.53? What math do I have to do? Can I do 78.53 divided by 2? Because I want half of that space. I always think about pizzas because I love food. So if I get a whole pizza and I eat 50% of it, I'm eating half. So if the whole area of that pizza is 78, then I can divide that by 2. 78, oops, I need to turn my calculator on. 78.53 divided by 2 is 39. Okay. So what would I do for the blue one? I need to find that whole area. So area equals pi times the radius squared, which means I need to do pi times the radius is 3 squared. What is pi times 3 squared? Pi times 9.
28.27.
Absolutely, 28.27. And then what part of that circle is shaded in?
Half.
So I need to divide that by 2 because I want half of it, right? So what is 28.27 divided by 2? Something like 14.14. What would I do for the green one? What math would I do? I got to find the whole area. So pi times what? Pi times 1 squared. That's going to give me 3.14. And then what part of that do I want?
That'd be 1/4.
It would be 1/4, absolutely. So I want 1/4 of that pizza. So 3.14 divided by 4 equals what? I got 0.78. So all we did, what we're trying to do is find this sector area. This little piece that's colored in is called a sector, right? That represents 1/4 of the whole circle. So if I find the area of the total circle, and then I divide it by 4, I get that one little piece, that one little green piece. For this one, for the blue one, I found the area of that whole circle, that's the 28.27, and then divided it by 2 because I only care about half of it. For the red one, we did the same thing. We found the entire area of the circle, and then we divided it by 2 because we only want half of that circle. What about for the yellow one? What's the area? How do I find the area of that? Pi times 2 squared, right? Absolutely. So if I do pi times 2 squared, the area of the whole circle is at 12.56. Sometimes you do these so much and you just memorize them. So the whole area of the yellow pizza is 12.56. And what part do we care about? What fraction? This time we want 3/4 of it, right? So we want to multiply it by 3/4. What is 12.56 times 3/4? So all we do is 12.56 in the calculator times 3 divided by 4. We get 9.42, question mark?
Yes.
Okay. So we've talked about our equations of our circles. We've talked about finding the circle center and the radius. We've talked about finding the area and the circumference. Now we're just stepping that up by a little bit and figuring out a percent of the area, or in the next slide, a percent of the circumference. So if I look at this green arc, all I care about is this line around the edge. So this is part of the circumference. So this time I need to use the circumference. So 2 pi r and then divide by 2. So what is 2 pi r? 2 times 3.14 times the radius, which is 1, 2, 3, 4, 5. And then I want to divide it by 2. So what does that give me when I do that in the calculator? 3.14 times 5 times 2 divided by 2 is?
Would it be 15.71?
Absolutely. I got 15.7 because I rounded. We can get 15.71. You probably use the pi button. What about the red one? What math could I do there? Oh, let's not do the red one yet. Let's do the yellow one. What part of the yellow circle do I want? That's 1/4 of the way around. That's 2/4 of the way around. That's 3/4 of the way around. So I'm going to do pi times the radius. What's the radius?
I have a question.
Yeah.
How do you, what fraction do you put? Or like what number is supposed to put?
So that's a really good question. This one, if I cut this into slices, this is 1/4, 2/4, and 3/4. If I slice this one, this is 1/2. If I do the blue one, that's 1/4. And then the red one is tough. That's why I wanted to leave that one for last. That one's more than 1/2, but less than 3/4. This one is in eighths. So it's 1, 2, 3, 4, 5 eighths. And in the interest of time, I think maybe I want to stop here and I want to go meet somewhere else. So close those Jamboards. You guys did great. I know it was a little confusing. And I want you to open up this. So there is a slides link, but I'm going to give you the Pear Deck link too, because then you can write on it. Boom. And I'm going to come here. Let's see, because Isis, you asked such a great question. How do I know? Does the slide work? Does it take you to the Bright Pear Deck?
Yeah.
Let me give you some notes. So this is the page that's straight out of your notebook, right? So the videos won't work in the Pear Deck, but if you go to that digital notebook for circles, you'll find this page and then the videos will work. So we're kind of rushing on time. We've got 20 minutes, so I think we have plenty of time. But if I rush too fast, you can always look at these two videos. Okay? Again, they won't work in the Pear Deck. You'll have to go look at the digital notebook. But what we're looking for is arc length. So that's what we were talking about. I want just this piece of the whole circumference. So it's almost like a proportion. We're going to do this degree, the degree of what we wanted, right? And in the Jamboards, we were just using fractions or percents. This time I'm going to give you degrees. So whatever that missing degree is, over 360, because that's the total. So it's always the piece over the total. And then we're going to multiply by circumference if we want arc length. Or we're going to do that very same thing, the angle that we want divided by the total times the area for the sector area. So if you're just looking for a piece of the edge, you want to do the part over 360 times the circumference. If you want that whole area for a sector, you want the part divided by 360 times the area. So let's see if we can do a couple practices and see if we can make that make a little bit more sense. Come down here. Which equation are you going to use? If I'm asking you for arc length, is everybody with me on this slide? Okay, so I want you to write as I write. What is the arc length? Which equation are we going to use? The one that says length, right? It sounds like a crazy question, but sometimes we don't use the right ones. We want to do the part over the 360. So this is the part that I want. That's 315 degrees divided by 360. And then I'm going to multiply by the circumference because I want length. So that's 2 pi, and then my radius is 11. You're just going to put that in the calculator exactly the way you see it. So in your calculator, whatever calculator you're using, 315 divided by 360 times 2 times pi times 11. Did you get 60.44 or something close to that? And it says round to the nearest foot, so we can just round it to 60. Couple people asking about the V's. So at the end of this, let me go and do some of those V's together with you in IXL. Did this one make sense? Kind of, sort of, maybe? Let's see if we can make some more sense with this one. Again, we're asked for what? The arc length. So arc length, we're going to use circumference. What do I put on top of the fraction? Which number? 270, absolutely. So the part over the total, always the part over the total. And then because I'm looking for length, I'm going to do circumference, 2 pi, and the circumference is 13. And then it's just calculator work. 270 divided by 360 times 2 times 3.14 times 13. And what did we get? Again, we're rounding to the nearest foot. It's very close to the last one. I got 61. Did anybody else get 61?
I do.
Okay. I don't want to go too fast, but once we get the hang of these, they're really easy. Okay, here there's no picture, but sometimes that's even easier. We're still looking for arc length, so we're still going to use the part divided by 360 times the circumference. So I know my part. That little theta just means the angle. So 60 over 360 times 2 times pi times 18. And then it's just a matter of the calculator. 60 divided by 360 times 2 times pi times 18. And we get what? If we round to the nearest whole number. Awesome. Don't just trust that my answers are right. Make sure you're keying it into the calculator yourself, because sometimes, you know, the calculator app does weird things, right? We've done 3 together. Now I want to give you time. Oh no, I should have done this on the last one. This third question changes a little bit. How does it change? What's it asking for? The area. So how are we going to do this one? Now that it's asking for area. Same thing, we're just going to change to the area formula instead of the circumference formula. So what goes on top of my fraction? Still the 60 degrees. The 360, kind of like the hypotenuse and trig, always goes to the bottom. And then I've got the radius is 10. So 10 squared. That's the thing that a lot of people forget to do when they're doing this one. And then calculator, 60 divided by 360 times pi times 10 squared. And what do we get? 52. 52. Loving it. You guys try the next one. So this is a big angle, but it's still the part. 360 always goes on the bottom. We're looking for area, so we've got to use the area formula. 14 is our radius. Oh, I definitely did not do that right. What'd you get? It's a pretty big number.
Would it be 539 instead of 38?
It would. So 538.5, that's a 3/8, is going to round to 539. Absolutely. What about this one? How do I set up this formula? I hate lagging computers. So do I use area or circumference?
Area.
Area. And what number goes on top of the fraction?
60.
And this one says round to the nearest tenth. So what goes for the 10th spot?
7.
I got 643. Did you use the pi button or 3.14?
I used the pi button.
Okay, so if you use 3.14, you're going to end up with this. If you use the pi button, you're going to end up with this. Both of them will be right. Am I going too fast? Are you guys okay? Am I starting to sound like a robot? That's my internet. It was being super fritzy yesterday. So here it changes up a little bit, but it's still the same problem. So if I read the question, I'm still looking for length. So I'm still going to use circumference. EB equals 15. So now I just need to know that that's my radius. And then I still want arc CD. Oh, but arc CD is over here. So what's this measure? If halfway across is 180 and this piece is 68, what's the missing piece? I've got to do 180 minus 68. 112. So if I'm looking for this arc, I need to use that 112 instead of the 68. So there's one extra step. The process is still the same. And then I'm using the length. So I need to do 2 pi times 15. And then what do we get for the length of that arc?
$29.
Awesome. Did anybody else get 29?
Yeah.
Awesome. So this little piece translating that you want this part and getting that 112 is the hardest piece of that question. So they're not always so straightforward. Sometimes you got to kind of translate the problem. Going to do the same process. Try this one on your own. And when you're done, let me know what you got in the chat. Nice. I got 6.59, which is definitely going to round to 7. Perfect. Last two questions. This one changes it a little bit too. Jenny's birthday cake is circular. So there's no picture. I always like to illustrate it. And has a 30 centimeter radius. That sounds like a big cake to me. Her slice creates an arc with a central angle of 120 degrees. So that central angle is this one here, which means the outside is also 120. What is the area of Jenny's cake in terms of pi? So this time we're going to not multiply by pi. I want to do area. Do I know what the x is? What goes on top of my fraction?
120.
120. And area is pi. And then the radius, what was the radius again? Because I have pi in my answers over here, don't multiply it here. If you have pi in your answer choices, don't use it in your calculator. So all I'm going to put in my calculator is 120 divided by 360 times 30 squared. 120 divided by 360 times 30 squared. Once you get that answer, whatever your number is, you can add pi to the end of it because it just kind of comes down. So when you get your answer, put it in the chat or just unmute yourself and let us know what you got. $300, absolutely. So sometimes these questions just take a little bit of translating. If you take the time to kind of draw a picture and go through all the steps, they should be pretty straightforward. This one changes it a little bit too. The circumference of circle C is 144 pi. So circumference equals 2 pi r, or it equals pi d. And we know that equals 144 pi. So if I look at this and I divide by pi on both sides, my diameter equals 144, which means my radius equals what?
Would it be 12?
You would think, because it's a perfect square, that you want to take the square root. We're so conditioned to do that. What's the relationship between the radius and the diameter?
Well, the radius is half of the diameter.
Absolutely. So if the diameter is 144, what's the radius?
72.
72, right? And it's so tempting to say 12 because we're so conditioned with area for it to be r squared. So be careful with those. 72. So now we can find the length of arc AB. Arc AB is at 120 degrees. So 120 divided by 360, times, and then we're finding the length. So 2 times pi times 72. Do you get 151-ish?
Yeah.
So we are almost out of time. I do want to real quickly, if I can, we might have to do this tomorrow. So yeah, let's do this tomorrow. We'll talk about the IXL. I do want you to try to do the green puzzle piece tonight. There'll be 2 attempts. So try it tonight. Do what you can and submit it. I need to know what you know and what you don't know so that we can talk about it tomorrow. Okay. So try this puzzle piece. You'll have 2 attempts. It's not due completely the second attempt until tomorrow, but the first attempt needs to be done before class tomorrow. We do have a boot camp today. So if you want to come to boot camp, we're going to talk about parallel lines, slope, all of that kind of stuff. But class is over. I'll see you guys tomorrow. I hope you have a great day.
Is that true?
Yeah.
Remember